If we're going to create commands like this, what we probably want is to pass some data as well, structured data. So let's clear all of this noise, and we'll see one other moderately helpful thing that we can do with discord.py's command mechanisms. We can give this callback some additional annotated arguments. And when we give it those annotated arguments, they'll actually set up in the Discord / command the ability for us to unambiguously mark particular inputs that we happen to have. So let's say that this takes a numeric value, and we'll annotate this and say this is an integer value. Give this a second to get started. Then we'll switch over here. We'll say test, run our test command, and you can see it takes a numeric value. We have a name for this argument, and here we'll see if we pass in a non-numeric value, we actually get a client level error. Great, because this gives our users a little bit more guidance on what to expect. Here, let's give a numeric value, and there we go. We actually got that numeric value, and it just came in as a regular positional argument for this particular function. And so if you thought about what you could do with this, well, I remember back in the day when there were chat rooms, people used to like to do things like play card games in those chat rooms or play dice game in those chat rooms. And so you could think that what we could do with this is we could do something like create a simple dice roller. Here, let's rename this test command to something a little bit more descriptive for what we want to do. We'll call this dice. This is roll n dice with m sides. We'll give it n and m as the arguments. And let's pull in our random module. Here we're going to do a rand range. Actually, we have to do a rand int because rand range won't include the m pointer. It'll be a little bit ugly. And then here we can say our results equals rand int from 1 up to m or whatever in range n. We could say our dice is equal to whatever the results are. Let's comma separate these. We'll do it like this. We'll join this and we'll format this. And hopefully in future versions of Python, we'll be able to make better use of some of the f-string improvements, make this a little bit nicer to read, but there we go, there we go. And we'll also put out the total. Very good. So we should have everything we need for our simple dice rolling Discord bot. Let's see how this works. /dice and an M. So let's roll 3 10-sided die. And of course, we need to make that an F string. So let's fix that one mistake. And of course, once we do that, we'll just have to double check everything there is good. This is good. This is good for X in results. There we go. And try that one more time. 3 10-sided die. And there we go. We got a 6, a 4, and an 8 for a total of 18. So it's actually relatively easy for us to write these simple controlled interactions, which involve not only the bot responding to you, but responding to you in a very, very structured fashion where you can constrain what the inputs are. The unfortunate things here are the Discord API doesn't give us that many choices for what the options can be. We can have integer values, we can have string values, but you might think that things like date pickers would be useful, and I don't believe it gives us the ability to do date pickers. In fact, if we try anything too exotic, by a datetime.datetime, and see if it gives us the ability to do that, we'll get an error right here. You can see unsupported annotation type, but of course we have strings. And so we might end up having to just kind of smuggle some of that data into a string and then parse the other side. So here if we want to do something like it rolls a die on a time message, we could use, from dateutil.parser import parse and then parse it from a string, which is maybe about as good as having a date picker, maybe not as precise, but still quite flexible. So we can see that a lot of this behavior is pretty straightforward. Now, here's where it's going to get a little bit dicey. What we want to do is we want our Discord bot to be able to hold on a conversation. And by conversation, we don't just mean the actual contents of that conversation, the hello and the goodbye, but what we want is some interaction that is deeply stateful, where along the way, as part of the interaction with the user, we're tracking some things in the background. In order to keep it simple, what we'll track in the background is where we are in the conversation. But in general, that could be any information that we might want to track. For example, how long the conversation's been going on, when the conversation started, how frequently the user is interacting with you, whatever the case may be. And we might wonder how we might go about doing this. Fundamentally, in discord.py, we don't control the event loop. And I want to talk briefly about this particular model of programming. It comes up quite often. We have an idea of what we might call a retained mode versus an immediate mode API. And we see this idea come up not only in GUIs, we see it come up in, for example, the structure of these agent models or these bots, as well as the structure of even things like visualization frameworks and dashboarding frameworks. In general, when we talk about retained mode, we're talking about cases where the event loop is not under our control. And in immediate mode, we're usually talking about cases where the event loop is under our control. Just to remind you what I mean by event loop, somewhere lurking in the background of all of these mechanics is an actual loop. And this loop is interacting with the WebSockets layer. It has something that looks like this, a while true in it. And it says something like, wait for a WebSocket message, code message, dispatch the message to some callback. And there we go. And in fact, if we take a look at the discord.py code, we can even see that very, very clearly in this code. Here we have the discord.py code. Let's go into, not of course the docs, but into our Discord client.py file. And if we take a look at that def run, how we trigger this, we'll see that this ends up calling start, which gives us a little bit more control over where the login happens. But here you can see there's a start with a login and a connect. And if we find that connect, we can see that there is basically an infinite loop where all of the data flow and the control flow is handled for us. Here, this is our infinite loop. You can see while the connection isn't closed, you're creating a, you're actually getting in a WebSocket message, and you're dispatching that message in some fashion. Here you can see, let's see if we can actually pick this up. So here you can see it's polling an event, and if we dig a little bit deeper, we can find exactly where the steps are. But what's most important here is that we have this blocking while true. What that means is we fundamentally don't control the order in which those callbacks are called. And so it may be the case that we might have to have a callback that gives us some life cycle before this event, while this event happens, after this event happens, because we just don't control where the events can be called. They're controlled in this loop. What that also means is it may be very clumsy for us to register new events. For example, if we see a WebSocket message, we can't really escape the constraints of what events have already been set up. And critically, we can't pass data between these very easily. And so, for example, if it were the case that we wanted to pass data from one conversation to another, well, how do we do that? If we were to use the simple on message mechanism, well, that looks like this: client.event async def on message. Multiple of these asynchronous tasks can be running at the same time. We have one asynchronous task for each message that's in flight. Well, how do we have one message over here in one channel, share information with one message over on the other channel? Well, we don't control any of that control flow or that data flow. So we're going to have to smuggle that basically through global variables or through some kind of class state. Very likely what we'd have to do is we'd have to do something like create a class here, and then we'd have to say something like, self dot We have to make this an instance method and self dot shared state equals whatever. But probably since we can't really create multiple instances of this client at the same time, this really isn't altogether that much different than just having some global variable that maintains that shared state. This is the nature of our retain mode UIs or our retain mode structures. In an immediate mode structure, what we'd have is the ability to define our own event loop. And so we would control the event loop. We would write the loop. And in the loop, we would trigger the particular actions that we want. So we do something like await, receive message. We do the dispatching ourselves. And as a consequence of controlling this, we would control that data flow. And so we wouldn't have the same limitations. But this just doesn't happen to be the way in which the Discord API is written. So